Doktor, nak
Yes.
tanya yang nanti ada discussion untuk sesi test tu ke?
Discussion on what?
Cara
answer.
menjawab. Jawapan the answer.
Okay, let me finalize first related to your friend problem. It is not related to our section only. It is cross section, so we need to carefully find out what is our solution. After that, we will going to discuss about the answer. Okay.
Okay lah.
Okay. And for those who ask me who marked the part B, the lecturer is very strict. We also like shocked. Although like 0.5% also you're not going to get, although you have a final answer. So yeah, we still trying to discuss. Hope that you doa banyak-banyak, you pray as many as you can. What, as mentioned last time, what you need to do is you study. After you study, you try your best in your test. And lastly, there is nothing that you can do. In Islam also, you need to do what? Just doa. So pray, many, and then open others lecturers' heart to accept. Might be give you deduct marks or I don't know. Yeah. Hope the best for all of us. Okay. So let's continue. But it's good for you to try, accept your mistake, try to figure out what should us to help you in terms of the solution. Trying is good. So keep trying in any things. Although that you feel like, "Alah malunya," or I feel shy, or I feel that I don't want to do that. But trying is not something wrong, and trying didn't give you anything. It give you a positive later on if they are accept. But if they didn't accept, you didn't get nothing. But it's okay. At least you try. So just practice that. I still getting WhatsApp from others. My answer is correct, but I don't get correct answer. And also, how you get this? You must show all the work to arrange. Okay, I'm going to entertain them later on after this. Okay, yesterday we did look into step by step how you're going to get your synchronized counter design. Step number 1, 2, 3 until step number 6 I already shows you, and even you already look into how to get the excitation table. To create your transition table, you need to have the excitation table. Yesterday, I showed you on the JK flip-flop. From the scenario, from the situation day, then you come up to have your execution table. This is the thing I ask you to remember. But don't just remember, please know how the derivation you get to conclude like this. Okay. Then yesterday also all of you already done together with your friends to contribute the development of exhibitions table for D flip-flop and also T flip-flop, and I already discussed and shows you the steps. And here also there is a there is a diagram, state diagram for you related to this x-axis. You can see when you have two scenarios, there is a possibilities for you to get x there. What is x here? This x can be 1, it can be also 0. Okay, if you still remember, there is step number 5 here, asking you about K-maps. And there is one of your friend asking me about the x function in your K-maps. Okay, this is the K-map things. I can't remember, I think in your module 4 or 5, but I want to repeat. The things that you need to consider and look is for K-map, you need to group digit 1. You need to group digit 1. How about x? 0, of course, you're going to totally ignore. But what is x? X, function x is to help digit 1, to help, okay? Digit 1 to get bigger group. If your x not going to help 1 to get bigger groups, then you're going to ignore. If x can help 1 to get bigger groups, then you're going to consider to be as a 1. So here you can see, you need to find the adjacencies for this 1 here. So you find out here, you're going to ignore, but you have this axis here. What is the function of x? X is to help 1 to get bigger group. So I can assume it's to be like this. How about this x? I'm going to ignore because it's not helping this 1 here to get bigger group. I know that I cannot do like this. And even the one that you follow expert, or I don't know, you follow your friend, you do like this. I never ever teach you like this, and I already inform you we cannot do like this. There is no just this group for your K-map, okay? So I hope that you totally clear about your access, because you still need to know how to simplify, how to get your Boolean equation for upcoming final exam. You still need to know, although it is like at module 4 or 5, which is not covered in your final exam. Your final exam will be covered 7 onward, but still you can see here you still need K-maps. So for those who still don't know how to group, how to get the equation, please go back and look into the K-map. If you don't know, you can direct call me, because there is a lot of WhatsApp. You can just call me if, let's say, you say, okay, doctor, I give you WhatsApp, but you still didn't reply. I'm not going to scold you. I'm not going to feel like angry because you tried to ask me question, but I didn't reply. Instead, I was thinking, oh, that is what was my fault because I didn't reply WhatsApp. So if I didn't reply, you can WhatsApp me in my group, in our group, mentions, doctor, you didn't reply me. Or maybe you can direct call me, doctor, you didn't reply me. Can you check my WhatsApp? So I will try my best, okay? It's good for you to ask question, but sometimes there is a lot of question. Sometimes there is a lot of WhatsApp, so I can't to reply. And then after that, I forgot. I didn't scroll. So if you look my WhatsApp, there is a lot of unread WhatsApp. So you can see 500 something. It's there are too many. So I hope that you understand my situation. I'm not purposely ignore you. But maybe I can reply like 1, 2 student, and then suddenly there is a lot of things I need to do. I forgot. So your WhatsApp is already goes down. So I didn't scroll until down. So that's why it's happened. So what I suggest is, if you think that, don't think that I purposely ignore you. Please just think that, okay, I didn't realize. You can spam me. You can also call me, okay? So next, we're going to look into step by step here. Yesterday, we already looked into questions and example for our 2-bit synchronized counter. When it's up to 2 bits here, you know that you have 2 flip-flop. And what is the type of flip-flop? Here is JK flip-flop. So you know that J0, K0, J1, K1. How to draw the timing diagram, also you need to know about the flow of this arrow. And what is the look of your next step table? You're going to have the previous and next step. How about this? This is depending on bits here. How many bits you have? If you have 2 bits, you're going to have 2, Q0, Q1. If you have 3 bits, you have Q2, Q1, Q0. If you have 4 bits, you're going to have 3, Q3, and similar also to your next step. So this is the look of your next step table. And then okay, related to the question, you can see here the question just asks you, let's say, to design 2-bit synchronized counter. Of course, you can like directly give your answer. Okay, this is my design, doctor. It is correct. Why I get 0? Because step number 1, step number 2, 3, 4, 5, 6, all these 6 states having marks, and you didn't show your marks suddenly, you didn't show your steps suddenly, you get final answer. So what do you think about the final answer? How many marks that you going to get? So please make sure you know all the steps and show all the steps. Last time, if you still remember, I inform you, don't do your step in your rough work paper. If you think that you want to chonteng, if you want to put anything, you say, oh, this is very mess. You don't want to this chonteng thing, this is ugly handwriting to be submitted. But you need to take everything into your beautiful answer script. But for me, last time I mentioned to you, don't do anything in your rough work because you're going to forget. This rough work is totally give you marks. Maybe we're going to find, maybe you put here, maybe you put here, maybe you put here, maybe you put here, but still there is a step for you to get the final answer. That is the things that we want, not your final answer. That's why last time I mentioned to you, please make sure you write everything in your final answer script. If you write in your rough or rough paper, copy it back following a sequence to your answer script. Okay, so all this step is important. What is the next step table? And then you can see on the transition table, you have your next step table and also your JK things. If it is D flip-flop, it is about D only. So this is how it's look. You have flip-flop 0, you have flip-flop 1. And from this, how you're going to get all the value? You're going to refer to your excitation table. That's why I asked you to remember this excitation table. Okay. After that, you have step number 5 here for care maps. Sometimes you feel like I also going to be like confused because it is play around with Q things. It is J. Last time you normally play around with like A, B, and then you have X or even F to be your output. But it is totally similar. Only in terms of the variables make it different. Okay, so this is step number 5, and lastly your step number 6 is for you to draw back every single things into the circuit. Okay, so after that you look into the timing diagram also. This one now you are referring to same clock. And only the different when you need to consider at this clock what is the value of Q, at this clock what is the value of Q, because this Q value will going to affect your output for your Q1 because it is the input for your J and K. So we also look up on our 3-bit synchronized counter also. Similar step. As long as you know the step, you did it slowly, then you going to get answer. And yesterday I also shows you can also come out with this kind of table. Q2, Q1, Q0. It is totally similar to here when you are drawing your answer. Might be it's going to be here also. I don't know how it's look like, but the final answer will be similar, which is J1 equal to Q0. I think this will be like here. Yes. You're going to get like this, which your answer will be Q0. Okay. That is about your counter, 3 bits, and etc. Today, as promised, we're going to go deeper to our 2-bit. Last time it is counter, and if it doesn't inform you about up or down, you're going to assume it's to be up. Where is it? Okay. 3-bit synchronized counter. Count. Please count. If you ask your youngest brothers, youngest youngest brothers, youngest sister, normally you say, okay, count. You play hide and seek. If you ask them to count, you mention count up? No, right? So it's going to be assumed to be count up if it doesn't mention. Unless you say, okay, okay, brother, please count down. Then they need to count down. But if you say to them, okay, start count, I'm going to hide. So then it's going to be count up. Okay, so this is the logic things you need to consider about this. But for the countdown, it's going to mention it will be bit 2 down. So it's going to count down. So countdown, you know, basically from 111, 10, 01, 00, it's going to continue and repeat things. Okay, the step is also similar, only that there is only last time you can see is followed beautiful, perfectly to this step by step. Last time, okay? But now for your next step table, you still need to do like this for you for your next step because it's going to make it easier. but might be going to confuse why I need to do like 0001, because here it should be 11 and then 10 and then 01. Yes, you can do that also, but in terms of your lecturer marking scheme and in terms of you to do the next step and etc., you're going to need to carefully look into the value. So that's why we're going to fix with like 0, 1, 2, 3. In this, we consider after this, it's going to be your input, right? So starting at this step 3, you need to do it. Because if you do it afterwards, after this, then here will be like 11, 01. So when you are going to use your CAM map, you need to check carefully. I am afraid that you mapping it wrong. That's why let's redo with the schema here following this step. After you did this one, because you know already the flow 00, 01, 10, 11. But how to justify this is when you are at 00, where you're going to go? You're going to go 11. At 01, you can see here, at 01, you are here now. Where are you going to go? Going to go 00. Now you are at 10 here. 10, where you're going to go next state? You're going to go to 01. And lastly, if you have 11 at the present state 11, you're going to go to the next state of 10. This is how you're going to map. You need to put this value first, not going to follow the sequence value inside, but the sequence value of counting 0, 1, 2, 3, 4, 5, depending how many bits you have. If you have more, then you're going to have more until 7, even until 15. So you need to know the flow only. After that, for your next step, then you're going to refer to your stat diagram here. If 00, where are you going to go? If 01, where you're going to go? Later on after this, you're going to see there is an example here. It's not example, it is about your synchronous counter you're going to give. You can see you have different state numbers. It's not follow a sequence, but for this you can see you're going to find out that you cannot having like following a sequence 00 and then 010 and then after that 101, 100, 111. So all of them will mess you until your step number 4, step number 5 onto the CAM map and etc. That's why later also you're going to apply the similar things in terms of the input. Mana? The present state should be in the following sequence. Okay, this is the only thing that you need to refer for your timing your stat diagram. So I already shows you. Okay, next, this similar you're going to tag and bring to your transition table. This is your transition table. And if you remember how to fill in the value of your D transition. Kejap wait, okay. Okay, how are you going to get? You're going to look into your excitation table. Yesterday, you already done and derived. If you think you still don't understand, you ask your friend to do. Please make sure you know how to get it. And if D, you refer to your QM plus 1, your D will be, if it is 0, your D will be 0. If it is 1, your D will be 1. So it's going to follow your D, isn't it? So let's take a look back the excitation table. See this one? If it is 0 for your Q n plus 1, your D will be 0. If it's 1, your D will be 1. So we go directly to here. We get here Q0. We're going to consider about D0 first. 1, it will be 1. 0, it will be 0. 1 will be 1. 0 will be 0. So I can conclude that I'm going to copy paste whatever in my next state to my D transition. This is only apply for D flip-flop, okay? After I have this, my step number 5 is pair maps. This is my output. Alamak. Okay, this is my output. So I'm going to do my I want to do a different from this example. Okay, Q1, Q. The example give you Q1 here, but I'm going to put Q0, Q1. Just to make you see that it's going to be similar for your output. As long as your value mapping is correct. So now my Q is 0, my 1 is 0, my D0, this is my D0, is 1. My Q0 is 0, my Q1 is 1. It's going to be 1. Betul dia satu tu. Okay. And then after that, if I have here for my Q0 is 1 and my Q1 is 0, it will be 0. And another one is 1 and 1, it will be 0. So I'm going to get like this, and my answer will be D equal to Q0 bar. How? This is the only thing that fixed throughout this box here. This one for Q1 is changing from 0 to 1, but my for Q0 is always 0 here. That's why I'm going to consider my Q0, but I'm going to put bar because it is 0. Remember back your POS, SOP, A equal to 1, A bar equal to 0. Okay. So, this is another way you can see here. The answer is, forgot to put the bar here, but the correct is Q bar, okay? And then you have another one. Let me draw mine. QD1, and I'm going to use a different also. Mine 1. Zero one, 0 1. I'm going to put Q0 here, Q1 here, because the question is different. I just want to make sure that I'm going to get the similar answer. Okay. Now it's D1. 0 0, it is 1. 1 1 will be 1. 1 1. The rest will be 0. Now I'm going to group. Okay, again, I didn't teach you how to group like this, okay? Don't do this again. So over here, when I have here, for this, I'm going to look into my input. My input is always similar for my Q1 and also my Q0. So my answer will be Q0, Q1 dot SOP bar and bar. And another one here, going to refer for my input value plus Q0, Q1. This is my answer. Let's check the similar things happen to Q1, Q0 mapping there. So you can refer your answer at the pages of 262 in your module on how your flip-flop look like, because it's going to be bigger. Let me try to draw mine. We can check whether mine is correct or not. I'm going to have D1 equal to and D0 equal to Q0 bar. Okay, this is D flip-flop. Of course, D flip-flop, if you still remember, we have the clock there that connected to the same clock. And this is my D0, this is my flip-flop 0, this is my Q0. This is D1, FF1, Q1. Okay, of course, you're going to have Q0 bar, Q1 bar. Doesn't matter, the important is on our connection here. Next, our D0. Okay, my D0 is connected to my, like this, because I got bar here. It is not. This is my input for DO. Now I'm going to do my D1. I can't see the green color. I don't know what happened. Okay, now I have AND gate, AND gate. See, although I said that it's going to be module 7 onward, still you need to know about the gates and etc. So I have here the input of this is Q0, Q1. And another one is there Q0 bar and Q1 bar, Q0 bar. And both is, kenapa dia jadi begini? Both will be O. And this connection, I'm going to fit into my D1 here. Okay, might be in this module is slightly more beautiful rather than my drawing here. You can check whether my answer is correct or not. Okay, so that is about counting down bit to bit. Any question? Oh, mak kosong. Any question? No question. Thank you very much because you help me easier my job. I will like teach, and then after, okay, bye-bye, meet you again. So, senang kan? It's very easy to be a lecturer. Thank you. So next, it shows here 2 bit up or down. So means that you can have both in your counter. Okay, let we draw counting down 2 bit, counting up first, 0, 1, 1, 0, 1, 1. Okay. Counting up here, 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 here. And then I have counting down also. What happened? I'm going to have counting down here, 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 and here. So both the counting up and counting down we call as a scenario of our trigger inputs. We call as X input. We can, but mostly you need to follow the maybe to follow the similar value. Counting up, X, or the situation will be 0. Counting down, the situation will be 1. So counting up first. If you have and you are currently at your stage of 0, 0. If you have a trigger of 0, you're going to count up to the next stage. If you are here, when you have a counting up, and then you're going to have here. When you have the trigger of 0, you're going to go up and you're going to go up. While for your counting down, you're going to have 1, 1, 1, 1. Okay, for this scenario here, there is 2 output. This is me. Okay, because I'm still single. Cantik lah sikit. Wait Okay, this is me. There is 2 men that I'm going to think to marry with. Might be if I was preferring, might be if let's say I'm preferring 0 as rich and 1 maybe at look handsome. Okay, which one that I'm going to consider? Maybe if I'm going to prefer for my rich, I'm going to go to this man. This is condition of 0. If I'm going to go to look into the looks or handsome, I'm going to go for 1. So there is also similar things. When you want to go from here to somewhere, you're going to have only 1 condition. You cannot have both. Like this. You cannot have like this. That's why at this part, go from me, go to somewhere, you only have 1 situation. When you go there, you cannot have the similar situation. You need to have either 0 and 1. You cannot have 1 similar and then another similar things. Okay, so if you want to have another example, when you want to go from Johor to any place, you have 2 ways, and then might be you're going to go to your right. Here will be to go to UTM. Here will be go to your college to sleep. Here will be your school of computing to study. So which one you want to go? So maybe this will be 0 condition. Okay, if you hardworking, then if you have hardworking here, you're going to go 1. If you are lazy, maybe you go to your college to go to sleep. So this is all condition. You cannot have this condition of lazy to go here also and similar to hardworking. You need to only have 1 choice. So in terms of drawing, please make sure when it go out, this is out, this is out, you're going to have different condition similar to also coming in. You're going to have only 1 condition and then both is different. So this is the stat diagram that you can have. It's too cold here. Okay, next here. We have thread next stat table. This one also you know already, but last time when you have 2 bit, you're going to have only 4 table. Present, stat, Q1, Q0, you're going to have 0, 0, 0, 1, 1 0 1 1. But now let's say here from you to go to where you're going to have two things, because you can go to school or maybe you go to your college to sleep. So there is two scenario, which is 0 or 1. So you can have 0 or 1. If it's condition of 0, you're going to go to 0 1. If you want, if you have condition of 1, you're going to go to 1 1. So this is your understanding that you need to have this. Here also it's going to have 2. Here also you have 2. Here we also have 2. But in terms of the looks, now you're going to consider this X to be another input. You have Q1, Q0, 0, 0, 0, 0, 0, 1, 1, 0, 1, 1. Of course, this is all the 0 condition. And we assume is to be count up. Slogan. And then after that, you're going to continue again to do similar thing. Similar scenario. 0, 0, 0, 1, 1, 0, 1, 1. But now our condition will be 1, 1, 1. You can see the flow here. It is from 0 to 7. If you are including this X value. But the scenario is the one I mentioned. You will have this only. But when you have two scenario up and down, you're going to have up, counter up situation and counter down situation. So you will get like this. At this situation, 0, 0, if you have input trigger of 0, you're going to go to 0, 1. If you have your present state now is 0, 0, 1. You are at here and you have the input of 0. Where you're going to go? You're going to go to 1, 0. If you are at 1, 0 here, and then you were given input of 0, then you go to 1, 1. Until the rest, you can map it by yourself there. Next, you're going to have the implementations of your K-maps later on. Before you can have this, you need to remember about your transition table. And I ask you to do what? Just copy and paste for D flip-flop following your next step. You can see you can copy everything. After that, you map it into your D1, D0. So let me draw something that different like this. X, Q1, Q0. This is my D0, okay? 1, 0, 1, 0, 1, 0, 1, 0. 1, 0, 1, 0. So I have this one. It will be equal to Q bar. That is my D1, D0. Sorry, this is my D0. How about my D1? It's going to be similar. I already mentioned, although my looks of table here is different. X, Q1, Q0, as long as what I map here following the input. This is my input, 0, 0, 0, 1, 1, 1, 1, 0. I'm going to look and compare everything. And I'm going to fill all together. 0, 1, 1, 0, 1, 0, 0, 1, 0, 1, 1, 0. So that is my answer. I'm going to get D1 equal to Q1, X bar Q1 bar Q0 plus number 2 X bar Q1 Q0 bar plus number 3 X Q1 Q0 plus last one is X Q0 bar Q1 bar. So that is the things I'm going to get. You can try to check your answer also. That will be the answer, similar things. Okay, now you can see the question asks you to draw. Although it asks you to draw here, but you need to do step by step. You need to do this step by step until you finally get your answer. You can refer to module 261. Okay. Any question for your 2-bit counting up, counting down?
Doctor, I want to ask about the K-map.
Okay.
Can you show the K-map for me? For the upper side, is it to exactly write the Q1, Q0, or can write Q0, Q1 on the K-map? On the K-map. Can we write Q0 then Q1?
Yes, can, as long as your mapping is following the value, as I mentioned.
Oh, I see. Okay, thank you, doctor.
You're going to get totally similar answer here as long as you refer to 0, 0 here is Q0, Q1. Q0, Q1, isn't it? So the value is, you need to see carefully. See carefully. If let's say over here it's 0, 0. Okay, I pick this one. Okay. For this one, Q0 must be 1. Q1 to be 0, and then X will be 0. So the answer will be 1. So you start here. Might be I can find different one. Okay, I'm going to help you to draw. Compared to this one, X, Q1, Q0. Q0, Q1. You want to do this right? Okay. We have here 0, 1, 0, 0, 0, 1, 1, 0, 1, 1. So I need to see carefully. This is my X0, Q0, Q1, 0, everything. It will be 0 here. And then my Q0 is 0. My Q1 is 1 here. So my answer will be 1. And then for the third one, this one should be 1, 1. And then for the third one, it will be this part. This part, it will be 0. And another one is 0, 0, 1, 0. So it will be this one. So I map another one is number 1. X is 1 here. 1, 0, 0. I'm going to get this as 1 here. And then 1, my Q0 is 0 at this part. So this will be the things. And then I have here 1, 1, 1. It's over here. It's 1. And lastly, at this part, it is 0. So if you can see, it's like similar, but if the answer over here maybe it's 1, 1, 1, then it will be different also. Okay, but your answer when you map it using your K-map, your answer will be similar. It doesn't matter, I mentioned about how you're going to use your mapping here. Only you need to know the value and you map all together which part. Okay, for now over here, for this part, you have Q0, Q1. This one is Q1, Q2. For this, what is the specific? It will be at 0, 0, 1. Let's look at this. But for this one, it's look at this part. Okay, this one is for here. And these are referring to this. Same place, but you're going to refer to different value. If here is 0, then you're going to get different also. As long as you understand how to map, okay? So any other question? If no, we're going to continue with this, another one.
Doctor, can you please draw the circuit for the previous one? The circuit.
Again, the apa?
The logic circuit.
Oh, the logic circuit. It's going to be quite bigger. This one is XO or XNO? This one is XO or XNO?
I think XOR or XOR.
I forgot the symbol already. See?
XNOR has a bar above it.
Huh? Like this, ah?
Yeah, overall bar like.
Okay, it's okay. XO, okay. So this is my D. D.
That was in the XO.
XO.
Yeah.
Okay, thank you. So here my FF0, FF1. This will be connected to my clock here, CLK. What else? No, okay. Now I have my Q0 bar. This is my connection, and another one, it will be XO. I have two XO here. My X. I'm going to have something called as X here. XO. First, I'm going to have this to be here, and I'm going to feed it my Q1 with my XO here, and this will be connected to my Q0. I done that part. This will be fed into my D1. It's quite ugly, but I think this is much more beautiful. You can refer to 261 at your module. Or maybe they are using the, because this one is QX, like 1, Q0 bar, something like that. And then maybe it is O gate, so it's much more bigger. But if you just use the XO, the simplifications, and you can have fewer gates to use. Okay, any other question?
Okay, thank you, Doctor.
Okay, so we can go for the counter for arbitrary sequences. You can see here, you can have this kind of design, but over here, you are missing something in between. Normally, you're going to have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, and etc. But you can see here, you are missing the 0, 0, 0. You know already this is 3 bits. by looking at how many bits you have. And then the valid states that you have only these 4. Another 4 is invalid. So this invalid state, what you're going to do, invalid, you're going to always refer to X things. Please don't care. So let's recheck. This is our situation. This is the table for present state. I always ask you to follow the sequence 0, 1, 2, 3 until 7 here. Then you have this. Because this is 3-bit, right? Then from here, your next step, I ask you to refer to your state diagram. So you have 0, 0, 0. Do you have the state here? No. Then you're going to put X, X, X. Second, you have 0, 0, 1. You have and you got here. And the next step will be 0, 1, 0. So you put 0, 1, 0. After that, you have 0, 1, 0. This is now here. What is your next state? You're going to go to 1, 0, 1. Here it shows you 0, 1, 1. Is there available here? No. Then you're going to put X, X, X. Another one is 1, 0, 0. It is also not here. It is X, X, X. And now we have 1, 0, 1 here. We're going to go to the next 1, 1, 1. And now at this also we don't have. And lastly 1, 1, 1. After that we're going to go to 0, 0, 1. So we done at our next stat table. For our transition table is including this T flip-flop now. If you still remember, that your T, you're going to have, if you have toggle, your Qn plus 1, if you have the value of 0 and then you have 1, it's toggle. If you have 1 and then it goes to 0, it's toggle, your T equal to 1. If you have similar 0, 0, 0, 1, 1, it is no change, then your T equal to 0. Remember back your T flip-flop, but you can also simplify looking at your execution table like where is the execution table? Like this. You're going to refer to your M plus 1. If it's similar to your Qn, previous one, which is no change. If it's different or toggle, it is 1. Similar to what I did just now, but I showed you in terms of the derivation. Mana dia? Okay, this one. So if you have different from your Qn, which means toggle, you're going to get 1. So what I'm going to do, I'm going to do T0 first for flip-flop 0. Flip-flop 0, I'm going to refer this and this. What happened here? You don't know this value. So you're going to put X, X, X. Next, we have over here 1 to 0. It's changed, it's toggle. So I'm going to put 1. After that, alamak, I don't have the value. If I have here, I'm going to do and then toggle, then I put 1. If X, then X, X. But you can see here, here and here, it is 1 and 1. You're going to put 0. So everything from your execution table here, similar step. And after that, you can draw your You can pick this, draw your chem map, and you can draw the diagram. It's not showing here. So you can try to draw using your T flip-flop, how the connection look like. And again, if you have here what I said last time, you have zero one zero 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 one 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 zero Q2 Q1 Q0. I'm referring to my T0 X1 1. Okay, because this one is totally everything is XO but 0. Okay, I can do it. Okay, this one will be 1 X. After that, I have X0 X0. So I can draw like this for my grouping, and another one is this one. So my T0 will be, for this I'm going to get Q 2 bar. And for this one I'm going to get Q0 bar. So totally I'm going to get like this. So of course my I'm going to draw. Okay, of course my T0 here, FF0, this will be my Q0. T0 will be connected to bar here, adding Q2 bar. Just assume to be like this, and this will be the input. So referring to your equation here. For this synchronous decay, I'm not going to cover, because it's going to take more time. Also, I want you to basically understand about this example, especially for this one. So we're going to continue with our next class. So for this, any question for your sequence, when you have arbitrary, means that there is something that missing in between. When you have something missing, your step is similar. But your step is similar. You have step 1, 2, 3 until 6. But you need to justify if the stat is not showing here, it's going to be X, 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 X.
So doctor, for this question, right? So the question going to give the state diagram before we going to do the table, right?
Yes.
So we follow based on the diagram that given to know the valid state and invalid state, right?
Yes. Correct. So later on, you can see also there is example. It give you the diagram. Oops. It give you the state diagram. You need to do the next state table. Sorry, because I bring my daughter today. She got fever, so I need to bring to office. So I'm not going to take my EL. That's why I continue. I'm afraid that you're going to slow until the final exam. So that's why I try to finish as soon as possible. Okay. After that, if you were given with the diagram, state diagram here, you're going to go to the next table, right? Next step. Next step table. So you just put whenever the value is not here, you're going to consider as X, X, X. After that, you do the similar thing, your transition tables. After your transition, your K-maps, and draw the final flip-flop diagram. So the following is or everything is based on last time I mentioned you basic things about your education table. If you don't know about your education table, you're going to start at your step number 4 here. Because for this one, you're going to refer your education table. Okay, any question? Maybe you can try to do the all exercise here. Yesterday video I've not yet downloaded. Might be tomorrow because today I also have class. I have class from 8 until 4 today. After this at 2 I also have another section. Okay, any other question? If no more question, we can stop our class and please scan your QR code for those who still not yet scan the QR code. And for the rest, maybe you can try to pray the best, not only for yourself, but also for your friends. Okay? So thank you for your participants. Stay safe. Do good deeds always. Bye-bye. See you again next week.
Thank you, Doctor.
Okay.
Thank you, Doctor.
Thank you,
Thank you,
Doctor.
Doctor.
Okay, bye-bye.
Thank you, Doctor.
Okay. Ui, sekarang.
Thank you, Doctor.
Thank you, doctor.
Okay, bye-bye.